Hello, my name is Renee, and today I'm going to be talking about energy. Um, I'm going to be discussing three fundamental types. I will be talking about one, potential, two, kinetic, and three, thermal. I'm going to do my best to explain how it is used and transformed from one type to another, but also from one system to another. So let's begin with potential. Potential energy is stored energy related to an object's position. So let's take, for example, a go-kart, that if we have it at the top of a hill, which it received its potential energy from another system, such as someone pushing it up there, and let's say once it has its potential energy relative to the ground or to its starting position, um, and let's say that its surface is frictionless, so that only gravity and the normal force are going to be acting on it. And now let's say that it is given a push, so our potential energy is now becoming transformed into kinetic energy. So kinetic energy is energy of which an object possesses by being in motion. It can also be defined as 1/2 times the object's mass times velocity of the object squared. So since our cart is on a frictionless surface, the sum of the cart's kinetic and gravitational potential energy doesn't change as it moves down. So we see that the equation 1/2 times mass times velocity final squared of the object plus the mass of the object times the gravity acceleration times its final y position is equal to 1/2 times the object's mass times its initial velocity squared plus the mass times gravity due to acceleration times its initial y position. And we will, this means that the kinetic energy plus the potential energy due to gravity is the same at the bottom of the hill as it is at the top. So we can see from our energy bar graph there that Ki plus UGI is equal to Kf plus UGF. So one thing to pay attention to also is that even though the car moves, the normal force does not play a role in our car's direction of motion, so therefore it doesn't affect its speed, as seen there from our picture. So let's elaborate further and say that our car's sum of kinetic and potential energies are its mechanical energy. So we see that K of F plus U of F equals Ki plus Ui as the law of conservation of mechanical energy. But we need an important topic. We need to be able to stop our cart, right? So we apply our brakes, which we have now introduced friction with our wheels, and as our cart loses kinetic energy, it is now being transformed into thermal energy. And thermal energy is the energy that is generated and measured by heat. And we know that mechanical energy is only conserved if the system is isolated and there's no friction there's no friction acting on it that is transforming kinetic energy or potential energy into thermal energy. And our brakes did just that to stop our cart down at the bottom. So that was my presentation of everyday physics object, or an object of physics in everyday life. I hope you enjoyed it, and thank you for your time.